So, I asked you the question, think about your local area and make a diagram of a food chain that would be typical for your area and put 6 organisms into the food chain. Let's see what happened. See what we came up with. Oh, chain, good deal. Grass, bug, rabbit, cat, hawk, human. I have never ate a hawk, but I'm going to go with it. All right. Okay. Fish eating plankton, big fish eating fish, human eating fish. That works. So we got like a perch and a walleye and a person. Plants, insects, small animals, large animals, death, decomposition. Good, very good. Oh, flower, bunny, lion, me. Barney eating you. Oh. Barney loves me. There's a song all about it. He would not do that. I'll tell you a funny story about the Barney song. I won tickets to REO Speedwagon singing the Barney song in downtown Traverse City when I was in high school. I'm not singing it again. I sang it for concert tickets. I went to Barney live. I have pictures. I have video of Barney live. I took my kids there at the Dow Event Center. Oh, I have some very weird connections to Barney, which I don't understand. Here, take that. I'm going to come hang out here. All right, so I got to get Barney out of my head now. I love you, you love me. Yeah, that one. Okay, so sun, grass, bug, rabbit, hawk, eagle. All right, I've never seen an eagle kill a hawk, but I'm sure they would. Human, chicken, corn. Whoa. Oh, chicken, corn, human. Or corn, chicken, human, yeah. Okay. Chicken, corn. Big fish, human. Fly, frog, small fish, medium fish. This could just go on all day. Fish, 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 fish. I can't even read that. Sun, plants, bugs, birds, snakes. Yes. Fast food. Sun, grass, cows, humans. I'm not reading that one. It should have gone away. I like the pictures. Is that Doug? Oh no, dog. Dog, cat, rat, cheese. What did the cheese eat? Oh. Hello, hello, hello. Oh, I like that one. Sun, grass, bug, rabbit. Yes, whatever that is. I think I got a snake and a. That's a mouse. I don't know what's going on here. Oh, it's a duck. Okay. This is more of a web. Yes. Okay, very fun. All right. So, folks, today, tone that down a little bit. Today we're going to look at how energy flows through an actual ecosystem. We'll talk about what happens to energy as it's transferred between different trophic levels within that community. But looking at trophic, if you look at just that word trophic, it reminds me of the word where, oops, that's Petri dish. It reminds me of that word trough, and I know it's spelled differently, but animals eat out of a trough, right? And so if I think of a trophic level, I think of it as a feeding trough or a feeding level. So the primary source of energy for an ecosystem is, of course, the sun. We've talked a lot about that already. Now, photosynthetic organisms such as plants and algae, we know they change light energy from the sun into energy that they can use to grow. They're green, they have chlorophyll, they go through photosynthesis. I think we generally understand that. Now, these photosynthetic organisms are called producers. They're called producers because they make their own food. And they are the basic food source for an ecosystem. Without producers, there is no food within any ecosystem. Now, consumers are organisms that eat other organisms instead of producing their own food. We are a type of consumer, right? I cannot walk outside and, hold my hands up and photosynthesize some sugar. It doesn't work that way. It'd be very interesting if it did. We would all have, lunch break would look really odd. We would look like we were possessed or something, or I don't know what movie that is where everybody stands and like walks outside all at once and goes, ah. What was it? Oh, in The Simpsons? Oh, yeah, like paranormal something or other.
Yeah, they're all,
Yeah, like that. Yeah. I always thought that'd be a good like alien invasion movie. Like. All right, so then we've got our decomposers. That's a bad color. I need to change that. So these decomposers, we know what they are, like bacteria, fungus, mold, things like that. But they're organisms that break down the remains of animals, and it's a pretty good thing we have them. A lot of people, I mean, we hate mold, and we don't like getting sick and having bacteria. But if we didn't, just imagine how much roadkill would be out there, right? Or how many dead bodies would be just there, of all different kinds. Humans, animals, insects, nothing would go away. Yeah. Eventually, there'd be no energy left in the system, right? Because it'd all just be there. So in an organ or in an ecosystem, when I go shh, everybody's quiet, and then I stop and start talking. It's not time to start talking again. Oh, I had 40 girls at a fall party at my house this weekend. 40 little girls. 40. Because I am not intelligent, and I let my daughters invite 40 children to my house. We had a fall Halloween party. We have it every year. But 8 of them stayed the night. Oh, never again will 8 girls stay the night at my house. Oh, till 1 o'clock in the morning, they were screaming at the top of their lungs. Between the ages of 7 and 11. Right? That was intense. So in an ecosystem, energy flows from the sun to producers to consumers to decomposers.
Did you just make a punny? I heard intense.
Well, they weren't intense, but we did use our cots to have them all stay because they don't have that many beds in my house. So, but usually the cots are intense. But no 40 kids did not stay the night. Eight girls stayed the night. That was including mine. That's 10 girls. Oh. So each step in the transfer of energy through an ecosystem is called a trophic level. Every time I go from, let's say, sun to grass, it's a trophic level. Grass to rabbit, that's another trophic level, and so on. We always start at the producers, trophic level number 1. So it goes something like this, from sun to producers to consumers to other consumers. Everything after a producer is a type of consumer. So after you make something, you can only eat it or somebody else can eat you, so to speak. Where do you think there's more energy at in this little chain? The sun, right? Okay. And so when I get here to the consumer at the end, there's less consumers here. And that makes sense. I mean, can you imagine if you had more birds than you had caterpillars? That wouldn't be right. You couldn't support your bird population, right? Right? So in the food chains, in ecosystems, energy flows from one trophic level to the next, forming a food chain. And you guys drew me some pretty fun food chains there. So why do we call it a food chain and not a food web? I'm going to ask that question to you. Why do we call it a food chain and not a food web? Because there are food webs. Why do we call it a food chain and not a food web? Because one has internet and the other one doesn't? No? See what fun stuff you're coming up with. Because it goes from one to the other, the webs link backwards and prey on one another. Chains are caused by reactions. Follows a strict line, because the chain follows a line, okay. So it goes only one way, follows a strict line, end of the chain, there isn't much living or eating. Caused by, okay, I don't know that one. It's not the whole ecosystem, it's just some particular organism's diet or the steps. Chains go in one direction because it goes, okay, it doesn't link back together. because they aren't all interconnected. I like the last one because they aren't all interconnected. So imagine like, I don't know, 10 different chains linked together, and then all of a sudden they start eating each other, and it goes in this, starts to mesh, right? And so it's tough to measure a food web. So we like to look at one chain at a time, one eating chain, like you guys drew me at first, bless you. So the chain is metal, okay, one's made of silk, yes. So the first trophic level of ecosystems are made up of producers. Plants, algae, and some bacteria use the energy and sunlight to build energy-rich carbohydrates. We know those as glucose, right? What is glucose? Glucose is a monosaccharide. You guys were all thinking that, right? Yeah, right? C6H12O6. This is like the goal of all plants. That's their food source. It's our food source too. So this first trophic level is where we find producers only. Every single trophic level after this is going to be consumers. Makes me think of consumers' energy, right? So the second trophic level of the food chain is made up of herbivores, which are producers. We know, which eat producers. Cows are an example of an herbivore. I had cow last night. Anybody have cow last night? Yeah. Cow tastes good, doesn't it? Yeah. So would we be, for those who had cow last night, would you be on the first, second, or third trophic level? Let me ask the question. Oh, you yelled it out. Third, right? Don't yell it out next time. Okay, so we would be on the third. Anybody eat just a salad for dinner? Yeah, but you had something else, right? Okay. I think I've had just salad for dinner one time, like once. It wasn't very filling, but I tried it. I usually have salad with my dinner, right? Unless you're a vegetarian, then you might just eat salad. Then you would be an herbivore, but not too many of us are. We actually eat both. We're omnivores, right? So the third trophic level includes animals that eat herbivores. Now, an animal that eats another animal is a carnivore. We are kind of a carnivore, but we eat both, so we're an omnivore. Now, some carnivores are on the third trophic level because they eat herbivores. So cats are a good example of that, right? Anybody know why cat food is so high in protein? Because they are on the third level. They're supposed to eat other organisms or other herbivores. They aren't supposed to really eat plants, cats. Dogs even. So other carnivores, I know it's unhealthy for them when they do. So other carnivores are on the fourth trophic level or at an even higher trophic level because they eat other carnivores. Think about carnivores that eat other carnivores. Are there very many of these? Think about it. Carnivores that eat other carnivores. That's like a tiger that eats a lion. Are there too many of those out there? Are there a lot of them? No. They're out there, but there's not a lot of them, right? Okay, because when I move up, every time I move up a trophic level, I get less of what was below me. And then there's us, the omnivores. Bears are animals that are both herbivores and carnivores. So bears, we know, will eat a deer, and they will eat nuts and berries as well. That makes them an omnivore. They're omnivorous. We're omnivorous. How do I know? I have molars for grinding plants, like my salad, and then I have canines for tearing and ripping flesh. And that's like the cow we eat, right? It's kind of weird to think about it like that, but imagine if you didn't have a fork and a knife. You'd still eat the steak. You just would tear it apart, right? So in most ecosystems, energy does not flow in a simple food chain. We know that. We study food chains so we can get an idea of energy flow. But energy flow is way more complicated than that. Ecosystems almost always have more species than a single food chain has. And in addition, most organisms eat more than one kind of food. And this complicated, interconnected group of food chains is called a food web. Now, I won't have you draw a food web. That would get really tricky. But I will show you a picture of one in a minute. But a food web doesn't have a single chain it follows. Like at my dinner, I don't eat just one thing. And sometimes things eat you, and sometimes you might eat multiple things that eat other things. And so you can't just stay on a single line in that case. So we understand a food chain is like here on the left, fish eating zooplankton, zooplankton eating algae, which is like a phytoplankton. And then here you have a food web. And I think I put this one in your notes, didn't I? I believe I did. Okay, so here I have a whale eating a leopard seal. I think that's what it is. I can't read very well from back here. Leopard seal eating the fish, fish eating the algae. But then I also have them eating all these other things like squid, and then sometimes the leopard seal eats the squid. And so it's not just one chain. I can count one chain there. There's another chain there. There's two chains. There's three chains, four chains, two chains. Sounds like a rapper. Is that a rapper? I thought it was. Oh, two chains. I'm going to make a test question about two chains, and it's not going to be a rap. No, it's going to be a web. Then we have an energy pyramid, which basically takes a food chain and it puts it into an energy model. So energy is stored at each link on a food web, but some energy is lost and it dissipates as heat into the environment, and it's not recycled. Is it destroyed, though? No, you can never destroy energy or heat, law of conservation of mass and energy, right? Now, when an animal eats food, it gets energy from the food. You guys are like, duh, Mr. Mason, we do that. And when the energy is used, about 90% of that is converted into heat and is dispersed into the environment. 90% of what you eat is lost as heat. That does not sound very efficient, does it? Don't worry about the one. I took it off. The one right above the web, don't worry about that. I took it off. Thank you. So this is what it looks like. Now, let me put this into kind of terms we can understand. At the very bottom here, this is our producers. Let's just say that's corn, right? Who eats corn? Herbivores, right? Like, yeah, I eat corn. It's not very, we can't do much with corn. It just kind of passes through us. But cows, you can eat corn, and they get energy out of it. Okay? They have a ruminant. And then small carnivores, that's like us, right? We'll just say that's us. I know we're not really a carnivore. We're an omnivore. And then there's large carnivores. Let's just say that's a tiger. Okay? All right? So we've got cow. Oh, why did I put cow down here? Oh, that's corn. Jeez. I need to write better. I can't do it with this device back here. All right, so we start with corn. Corn gets energy from the sun, and it takes all that energy in. Let's just pretend and make a number up. Let's say that is 10,000 joules or calories, we'll say. Okay? Let's say there's 10,000 calories there. How many are left? Actually, let's make it even simpler. I don't want to lose anybody with math here. Let's do this. Let's start with 100. That's easy. Okay? Let's start with 100. And then when I get to herbivores, how much of 100 am I going to have left? 10. And then when I go to humans, how much is left? 1. And then when I go to a tiger, I have 0.1. So if I start, let's say, with 100 calories of cow, by the time I get down to the tiger in this whole food chain, there's only literally one-tenth of 100 that I started with. So is there a lot of energy that's lost? I'm sorry about the beeping, guys. That normally is not an issue. It's because I'm using this microphone. But my other battery died, so it's I know. Let me go over here. Maybe if I move, it'll help. So if you take a look here, each energy level, you're literally losing 90% of your energy. That's why we have to constantly eat, right? Because most of the food we eat, that energy from it is lost as heat. Now, as inefficient as that sounds, it's actually relatively efficient. So by being a vegetarian, would that help our environment a lot? It would. I'm not about to do it, but it would help our environment a lot. I'll recycle. But here's why. It takes roughly 20 acres to raise one cow. When I say 20 acres, I mean 20 acres worth of corn, okay, is about what it takes. And corn, pasture, everything added together, it takes about 20 acres per cow. How much of that energy would I save? Imagine how much corn it would take to feed me, or not corn, but broccoli, corn, beans, everything that would be in your diet. It would not take anywhere near 20 acres to sustain me, right? It would probably take 1 acre, a 1 acre garden, and even that would probably be too much to take care of me for a year. But I could probably eat at least a cow in a year, right? So I'm utilizing like 20 times more land than I really need to, or energy than I need to, by eating cow in my diet. You get that? It's kind of a weird thing to think about, but it's because each time you take a step in this pyramid, you're losing 90% of what was there. So we can take small steps in our diet to improve our ecosystem and our environment and conserve resources. And if you look at this, it makes sense. So only about 10% is stored in the animal's body as fat or as tissue. That means 10% of what I eat is stored in me. The other 90% is burned off as heat. And this amount of stored energy is all that is available to organisms at the next trophic level that consume that animal. Is that also why we have more and more endangered species all the time? Because we're utilizing a lot of that energy and we're not eating off that first trophic level. Part of it is. If you go to Africa, do they have very many natural resources other than oil? Not a lot, right? Do they eat meat at every meal? No. Do they eat meat once a week? Maybe not. Like once a month, maybe, right? So you're looking at diets of different regions that are completely different based on this energy pyramid. In China even, they don't eat meat, especially red meat, at every meal. They eat a lot from the ocean, but it's just there's not that many resources there. So each layer in the energy pyramid represents one trophic level. We are a very different country than most. Most countries do not eat as much meat as we do. It's not a bad thing. It's actually good. It means we have a lot of extra resources. So producers form the pyramid's base, which is the lowest trophic level, and the lowest level has the most energy in the pyramid. Herbivores have less energy and make up the second level, and carnivores that feed on herbivores make up the higher level. Do we eat very many carnivores that eat herbivores? Anybody going to the grocery store and bought some tiger lately or lion? No. There's not enough of them, right? The closest we get to eating carnivores that eat herbivores is what? Let me see if you guys can think of it. I'm going to go ahead and just throw it out there. When do we eat carnivores that eat herbivores? Because we do. When? Blurt it out. Type it in. Let's see what you got. Fish, yeah, fish, chicken. Oh, chicken. I never thought of chickens because they're eating insects all the time, right? Oh, I never thought of that. That was a good one. Yeah. Some cultures eat cats. All right, yeah. You never know, right? You never know. Gator. Oh, yeah. Gators, alligators, whales. Fish for sure. Chicken, yeah, but you can, chickens, they aren't living off the bugs really, but they'll eat them. But yes, fish. Like, I just bought a can of tuna yesterday at the store. There it is. I got a carnivore that eats herbivores. That's actually a carnivore that eats other carnivores, right? Because big fish eats little fish. So the aquatic ecosystems are a little different than the terrestrial ones as far as their energy flows. There are a lot more energy levels in an aquatic environment. Now, the energy stored in the organisms at each trophic level is about 1/10 of the energy stored by the organism at the level below. so it takes on the shape of the pyramid. Now, big predators like lions are rare compared to herbivores, and we just talked about why. There's not as much energy. Now, big predators are rare because a lot more energy is required to support a single predator than a single herbivore. It takes 20 acres to raise a cow, right? Now, imagine it takes another 90% by the time I get to the next level, because the only way I'm going to have them is if they eat those cows. How many cows is it going to take to sustain a lion? I don't know. What do you guys think? Maybe, what if that's all they were eating? And they have to kill one, and then eat it, and then has to eat again maybe like a couple days later. I mean, that's a lot of cows in the end of the whole deal, if you think about it. What? Yeah, okay, let's go with that. 150 cows a month. Yeah, you aren't going to have a lot of lions running around, right? And you definitely aren't going to be killing them all, or you're not going to have them. So it makes sense. You look at your lawn or you look at the forest, there's a lot of producers out there. And then you might see a few of your smaller herbivores, but you're going to see a lot more of them than a carnivore. I think about mice. There's tons of field mice. Anybody ever walk through a field after it's been mowed down or hayed? Mice, or while you're cutting the hay, they just run everywhere. It's kind of funny. It's comical. You can't believe there's that many there, and they just take off everywhere. And you're like, oh my gosh, there's a lot of you here. But then there's hawks that fly overhead, right? Or snakes that might eat them. Okay? So here we have a snake in that same field. There are not as many snakes as there are rodents, thank God, right? Nobody wants that world. So they eat the rodents. We get that. So there's not as many snakes. And then you look, you might see one hawk in a whole entire field, right? So just think about a field and what you see there. You see the hawk. But what you don't see is the few snakes that are there and the many rodents, but you do see all of those producers that's supporting this entire ecosystem. Remember, less and less as we go up, because you lose 90% as heat throughout this system. So don't forget, in an ecosystem, energy flows from sun to producers to consumers to decomposers. The very important decomposers are the end game, right? They break everything down so it can cycle again. We are going to be talking about the cycles here in just a little bit. Now, energy is stored at each link in a food web, but some energy that is used dissipates as heat into the environment and is not recycled. So we don't get to recycle everything. A lot of heat is lost. Yes. I did, yes, indeed. There's another one there that I did cross out, so don't worry if you missed it.